Hi viewers, I have the graph of sine function. The question reads thus: draw the graph of y equal to 2 sine theta plus 1 for values of theta from 0 to 180 degrees. There is no big deal here. All you need to do is to recall how a linear graph is being plotted. So the first thing you need to do, I will encourage you to make your table. You have to illustrate it in a tabular form. This 2 here becomes the word amplitude. When we talk about amplitude, we look at how high the wave is. So on this point, you have your plus 1. That becomes the vertical shift. Remember, in your linear graph, you talk about things like what? Y-intercept. So the same approach. Now, all I need to do here is to make my table quickly. Our theta to be from 0 to 180 degrees. Funny enough, I can't number it from 1 to 120. Why don't we take it maybe as multiples of 30? At least 30, 60, 90, 120, 150 to 180. That will save us time. Also recall your words, how you scale your graph. So we can assume that to be what? 30 degrees to 1 unit, right? Here becomes my theta. Here becomes the 2 sine theta. Space 2 sine theta. When we have the vertical shift, which is plus 1 here, then the y, then our theta we can say from here 0, 30 degrees, 60, if our theta is 0, 2 sine theta will be what? 0. Yes, it's obvious. If theta is 30 degrees, 2 sine theta will be what? You know, sine 30 is 0.5, right? So 0.5 times these 2 will give us 1. If theta is 60 degrees, what will be 2 sine theta? Sine 60, what does it give us? Sine 60 is 0.86, then multiply by 2. 1.7, roughly. 1.7. Sine 90, that gives us 2. 2 sine 120, 1.7. 2 sine 150 will give us 1. 2 sine 180 is what? 0. You can confirm all these things using your what? Calculator. Then this is the constant value, the y shift. In plus 1 we have plus 1, plus 1, plus 1. Then we have to add 2 sine theta to 1 to give us 1. Then add 1 to this, you have what? 2. 1.7 plus 1 is what? 2.7. Here will give us 3. Here will give us 2.7. Here will give us 2. Here will give us 1. Okay, we are successfully done with the table. Now let's graph it. Quickly, here comes the graph. Our y-axis and the theta axis. So I've decided to make it multiples of 60 because of the space we have. So I can assume that here is 30 degrees, 60, here becomes 90, plus 30, 120, plus 30, 150, plus 30, 180. 180 plus 30 here will give you what? 210. Then you have what? 240, so on and so forth. So we are good to go. And this is our y-axis. At least I have it on the screen there, the table. We can say when theta is 0, y will be what? 1. That is where we need to mark. Next one. When theta is 30 degrees, our y will be what? 2. So it falls here. When our theta is 60 degrees, our y will be 2.7. This is 2, 2.1. You can see the tiny lines. 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. It falls right here. When theta is giving us 90, here is 90 because 30 plus 60 will give us 90, the middle part of this word, line graph. Now, when theta is 90 degrees, what does y give us? Y gives us 3. So trace this line here. Here becomes our 3. When theta is 120 degrees, our y becomes 2.7. Where's our 2.7? Okay, this is 2. Then right here, 2.7. Here becomes our 2.7. When our theta is 150 degrees, 150 degrees is in between here. 120 plus 30 launches us 150 degrees. So when theta is 150 degrees, our y will be 2. And this is the line of 2. Now when theta is 180 degrees, our y will be 1. This is the line of 1. It falls back here. So it continues. At this point, we now have to draw a curve, that is the wave. Now we go from down here, it must pass through the lines. Okay, here, coming down here, and here. Remember, we are talking about y equal to 2 sine theta plus 1. The graph of y equal to 2 sine theta plus 1, where our 2 becomes the what? Amplitude. Then 1 is the what? The vertical shift. That becomes how we plot our what? Trigonometric graph. Bye bye.